Okay, everyone, welcome back. Tonight, ooh, that is a little loud. Let's turn that down. You're early to the show, Robert. Not WPF tonight. So, I have been on a source generator kick. And so I've got some ideas of some source generators, and I've kind of talked about them and shown the results of them in a few other streams, but I figured I would go through and actually build one out tonight. So, specifically, the idea is there are what I would classify low-value unit tests. So I don't want to write them, but occasionally you run into a situation where perhaps the repository that you're working in has a fixed bar for you must have so much code coverage. And some tests will say don't add a lot of value, but if you don't write them, you lose coverage. So for example, you've got a class, takes in a couple dependencies in its constructor. Like a good programmer, you null check those dependencies. Problem is, that null check adds a branch condition there, if null, throw argument, null exception. Great, but unless you test all of those throw statements, you're missing out on coverage numbers. The problem is writing those tests is mundane, boring, and they don't add a lot of value. I had a colleague earlier to say, yeah, I won't dock you on a code review if I see those type of tests, but I'm also not going to tell you to write them either because they really don't add a lot. So what I figured is they only really have value for people who are being forced to do it for particular code coverage metrics. I've said it on stream before. My personal opinion is code coverage metrics are only good as a negative statistic, meaning you can't say that you have 75% coverage. You have 25% uncovered. I can't say the quality of that 75% that actually executed during your test, but I can tell you something about the 25% that wasn't executed. That ain't covered. So I think it's only good for the negative metric of how much isn't covered versus the positive metric of how much is. So my opinion, take it with a grain of salt. Welcome everybody. Lots of people chatting. So yes, agree with everybody. So let me show you what I started on. So my goal is to not write this for one project. My goal is to write this and then turn it loose on the world, which is a scary idea, but we're doing it anyway. So the AutoMocker library, which I think I've shown to people before, this is a library that me and a colleague of mine took over a while back, kind of around the time that .NET Core came out. The original author was swamped, didn't have time for managing it, and so he was kind enough to give us contribution rights, and we took off running with it. And it's been great. But the idea here is that typically when you're writing tests, the idea of creating the object that you're going to test, or the SUT, system under test, the constructor is a static call. Constructors by definition are static. It seems a little weird, but if you think about them as a static method that returns you back your instance, you get yourself conceptually in the right model. In C#, it's a little different. Constructors are more like an initializer. When you do when you call new object type, you get memory allocation and then the initialization. So memory allocation occurs first, then the initialization. There's kind of some back and forth in the order: static constructors, instance constructors, whatever. For the purposes of AutoMocker, the idea is if your constructor takes in constructor parameters, dependencies, it will go through and automatically populate those dependencies with mocks. And you can do all kinds of things to configure how it's going to do that populating. But the idea is then, as you go and add a new constructor parameter to your object, you don't need to go back and refactor all your tests to add that in. It'll automatically just do it for you. You only need to go and modify the tests that actually care about that particular dependency, as it should be. So that is what it is used for. To some degree, for people who watched my dependency injection stream like 6 ago, go back in the history like 6, you can almost think of AutoMocker as kind of a lightweight DI container, because it does run recursively too. So if your dependency is another class and it can look at its constructor and figure out its dependencies, it'll populate that and work its way all the way up. So it can kind of figure its way all the way back to where it's going. So what I did is I started a branch. And naturally, to prevent people from seeing it, I then didn't open my code up to show you, which is horrible. So for people who are interested, link to the repo. Link to the repo. Boom. Okay, and then anybody not paying attention, the test generator branch is the one. Oh, hang on. That's the real one. I want my AutoMocker. Sorry, gotta go back. This. I actually want this one. I want mine. So my fork is where the branch exists. And specifically, test generator. This branch. This is where we're going to play from. Or this is where I'm going to play from. Okay, so if we open this guy up, I pre-populated some stuff. And I'm going to just close all my tabs. Okay, so we're going to ignore everything down here because that's the actual AutoMocker library. We're going to focus up here. So I wrote a simple class called controller. It takes in a simple interface called iService. Just populates a property. This is that kind of meaningless code that I was mentioning. If you were to check the code coverage for it, you would have to pass in both the null and not null case in order to hit both sides of the if condition that's generated by this null check here. And you can see the interface is empty. There's nothing fancy. It's very simple. I then went and wrote a bunch of unit test projects. They all look remarkably similar. And so I wrote up the tests, and you can see live unit testing is on, and it conveniently points out that my test is now passing. But if I were to unit test this manually, I would do something like this. I would instantiate an AutoMocker instance. I would explicitly tell it to use null for the iService dependency whenever it runs into one. And then I would assert that when I call mocker create instance on controller, that it should throw an argument null exception, and the argument null exception should have a parameter name of service. And you can imagine if I were to go and add yet one more parameter to that class, I would then have to write another test. It would look remarkably similar to this, except for I'm kind of hard coding this type here, and I'm definitely hard coding this string. And in the past, I've written reflection-based solutions to this. Of okay, well, I can feed in a type, I can go looking for its constructor, I can do all that. Bleh, that's dumb. We're just going to skip all that. I figure I should be able to generate these tests with a source generator because there's nothing in here that I shouldn't be able to pull out. That's my working theory. I don't know of a reason why this fails yet, so we're going to try it and push it to the point where it does. Or I ship this. But the idea being that if this is your test project, I would love to have somebody declare a test project, something like this. And then, I don't know, AutoMocker constructor tests, right? Do some sort of attribute on it to indicate type. We'll see exactly how we want to go about doing that. But you'll know this class is generated partial. And then what I would expect to do is this test no longer lives here, but it lives in the partial class instead, which the source generators can build. So that's the plan. So for people unfamiliar with source generators, they are a magical thing that got added to the C# toolchain. It gives you an opportunity. Actually, hang on. I added, boom. Docs. Documentation is good. This picture is what I'm going for here. When you hit compile, the source generators get a chance to run. And you don't really get, there's some limitations to them, one of which is if you have a lot of source generators, there's not ordering to them, or at least you can't control the ordering. So you can't really get yourself, or I should say, you don't want to try to get yourself into a state where source generator A depends on source generator B. That's no bueno. But you hit compile, F5, Control-Shift-B, whatever. Source generator runs. It can look at your source code. Specifically, it looks at what's called the AST or the Roslyn C# compiler view of your source code. and you can investigate it, go through it, figure out, what you like, what information we need. In our case, what we would end up doing is, my thought is I go hunting for some attribute or similar, some trigger. And then from that trigger, I generate new source code, and that new source code gets added. Okay, that's the other big limitation with source generators, is everything they do must be additive. You are not allowed to mutate in any way. So you cannot remove code, you cannot change existing code that has already been written, that is about to be compiled. Now, even with those limitations, there's a lot you can still get away with. It just means you have to structure your code in such a way as to take advantage of a source generator. So for example, in this case, abusing partial classes, which is one of the things that they were really designed for. Before, we didn't have source generators, but we had other things that would generate code. But in this case, if we intentionally say, okay, we're going to go hunting for partial classes that are decorated with an attribute, let's gen this code up, away we go. The other thing I'm hoping to be able to do is, you'll note I wrote this same test with MS test, I wrote the same thing with NUnit, and I wrote the same thing with XUnit, because those are kind of the big three when it comes to unit testing frameworks. If you cover those three, you'll have covered like 95% of what people use for testing frameworks. But I was figuring for this generator, what I'm really looking to generate out, the only thing that are going to be test method specific is some sort of attribute at the top, and then the assertion calls down here. And so there's technically two assertions: assert that it throws the exception, and that assert things are equal. The thing to note is that all of the unit testing frameworks, a passing test is a test that doesn't throw an exception. That's it. A test is deemed passing if it doesn't throw. I'm going to comment this out so that live unit testing can be happy again. So if a test doesn't throw an exception, it passes. Now, what that means is there's technically a fourth case I could have my generator output, one that is unit test agnostic. Because in all of these cases, the assert class for the unit testing framework, all it does is some sort of condition, and if the condition is met or not met, throws an exception, failing the test. And so all of these assert methods are just thinly veiled wrappers around if condition, throw exception. That's it. Now, the exception that it throws is usually has lots of nice information on it, kind of gives you a hint about, hey, expected this, actually got this, what's wrong with you, whack, whack, whack. Most of them have friendlier messages, but that's the idea. So I could also generate, and I've kind of contemplated this idea, the idea of doing like a fourth target that's like unit test agnostic, something that where it just writes the if condition and throws the exception itself. Totally could work. Totally could work. So the goal is detect test classes that have been indicated, and obviously this thing here is going to have something like I don't know, target type controller, or type of controller. It's going to have something in here to indicate what the target type is that we need to create. But after that, I think we're probably good to go. Probably good to go. So that's where we're going. That's what we're going to try to build. I already got the test classes set up. So the goal will be, as soon as this thing can generate a test, to generate something that looks like this. So I'm going to comment this for the moment and go back to the original. But typically with source generators, as long as you can figure out what the code looks like that you want to generate, pretty good. Pretty good. Okay, so AutoMocker has a generators project in here already. We're not going to leverage this. This one exists here to generate out, or I should say this one doesn't get bundled with the actual AutoMocker NuGet package. This one just gets leveraged for generating out a bunch of overloads that we have. So we are not going to do that. We're going to create a new project. So creating a source generator, new project. And all of this is in that docs page from above. I'm just going to save you some trouble, and we're going to go a little quicker. Okay, so the hardest part of any of these things, naming it. I really should have thought about this ahead of time. So it probably should be, I can probably guess that it's going to go there. Yeah, we'll call it test generator. So this is going to end up creating a separate DLL that will ultimately need to package into the other NuGet. That will be a problem for another day. Okay, next thing to note. You cannot use Net 6 or Net 5 or Net Core 3 when building a source generator. The reason is because a source generator's DLL has to be loaded by MS Build when it's running the or I should not say MS Build, CSC exe, when it's running the compilation, which means you are limited in the run times. So Net Standard 2.0 is your friend. Okay. Can the generator as well as AutoMocker see and interact with the internal methods that were open for test via internals visible to? So, yes, but they do it in slightly different approaches. So the AutoMocker by default and Moq, M-O-Q, will only interact on things that are public by default. However, there are a bunch of methods on here that have use private, or what is it? Private, something or another, enable private. So because the fallback for these things, for AutoMocker to get into like internal stuff or private stuff, for practically speaking, those are more or less the same. You may need to set enable private, because that just ends up getting passed in as the binding flags in some reflection calls in order to get access to things. Now, if you have internals visible to set up into your test project, you probably won't need this for internal members. Again, I'm putting a little star there because it'll somewhat depend on your use case. When you set internals visible to, that typically enables your unit test project to interact with internal members as though they were public. As far as source generators get to view the code in the same way that the compiler does when it compiles your project. So protection modifiers, that's not an issue. What are you squawking about? Oh, also mildly obnoxious. This thing has a lot, or this project has a lot of static analysis turned on, and it's really hard to mess stuff up. Okay, so next step, and we can kind of just poke off of this generator. We need a class, and then more importantly, we need it to derive from this iSource generator. But in order to have that type, we need this NuGet package. So we're just going to steal it. So I could do add NuGet package, or I could just paste. And then just for not breaking the CI, we're going to set is packable false. Because ultimately, when we're doing the packing for this, we're going to have to do some fancy stuff. So for now, we're just packable false. Okay. And then we will grab this doohickey, come down here, and we'll call this test generator. Oh, I shouldn't have unit test source generator. Yeah, we'll do something like that. Paste, and then I need that interface and that attribute. And then implement interface. And just like that, we got a source generator. Okay, not really, not actually done. So first thing we're going to do is get rid of the throwing. And now we're going to add in, oh, we're going to fix this guy up. Boom, boom. Okay, now, normally source generators would get packaged into a NuGet package, and they will get, if you package them up appropriately into your NuGet package, they automatically will show up underneath this analyzer section when you reference the NuGet package. So you'll note by default, Microsoft has a bunch that you're getting. So secretly, you've already been using analyzers. And a source generator kind of falls into the same bucket in a lot of cases. So, but for what we want to do is we want to actually reference this source generator in my unit test projects, because ultimately the generator needs to be referenced by the project in which you want to generate code into. So if we look here, this is the magical thing that you need. So it is a regular project reference with this output item type of analyzer. So for example, if I come in here and I just do dependencies, add project reference, and I do test generator. Boom. If we look at this guy here, you'll see it's just done a regular project reference. But in reality, what we want, and we can just mutate the other one, is rather than this, we're going to not self-close that guy. We need the output item type of analyzer set. And then in this case, it really doesn't matter whether we reference the output assembly. Yeah, we'll turn it off. This is a unit test project, so it really doesn't make a difference, but we'll do it. We'll do it appropriately. So that guy goes there. And for now, I'm just going to pick on MS Test. We'll start small, but the intent should be that I should be able to toggle this in and get all the things working. All right, because this is the one we were picking on earlier. Great. Excellent. Okay. And now we get to start having fun. So when writing source generators, this interface is kind of designed to give you a really strong hint as to how you're supposed to do this. Now, this source generator here, this is an example of doing it the hard way and arguably kind of the wrong way. So you'll note this thing doesn't build up code normally. It builds it up with this compilation unit and trying to use the Roslyn members to generate out a ton of code. This is the hard way and not actually a great way of doing it. This is a maintenance nightmare, and I don't like it. The other thing is you typically want to separate out and in this case, there's really not a parse step. So this source generator is just generating a bunch of overloads to existing methods, which is fine, but you'll note it doesn't do any parsing of existing source code. It just generates some stuff out. If I go and look at one of these had my other thingy on it. I think I have it. Yeah, that one doesn't have one either. Really should find one. Oh well, I'll just talk through it. So when building source generators, there's a general structure that you want to adhere to for good maintainability. The pattern should look like first pass should parse the existing code or syntax tree and give you some sort of object model specific to what you're doing. In our case, our parse pass is going to basically build us up a list of test classes and their target types. Next, you should take that object model that you've built up, and the second step should be take that object model and write out the source code. Don't blur the line between those steps. Otherwise, you will quickly run yourself into a really hairy maintenance problem. So if you're looking for something that's maintainable, 2 steps, which is kind of hinted to you in these guys. So let's go in here and take a look. So if we go context and we go, where is the compilation? And then I believe this is where we start running down the syntax tree of finding all the stuff. Yeah, because we're going to find all kinds of stuff. Okay, so we need to figure out the appropriate way to get the information we want, because that's always the hard part. Let me look and see, because I thought I had a better sample generator to play with. I'm trying to look and see where I had written one. I think the XAML test one is reasonable, but let me... Here, I can just pull this over and we can look at it here. I think this one is a more reasonable example. Yeah, this one I think is a little bit more of a reasonable example. Are you going to use syntax receiver? Like that guy right there, maybe? Yep. Yep. So the syntax receiver, and actually we'll just, so if anybody's interested, I can share this repo here. So this is my XAML test library. It has a generator in there. It uses the generator because I was not going to write all of the classes for every WPF UI thing out there. So it comes prepackaged with a generator that rips through all the WPF UI classes. And I believe it adheres to the general structure a little bit better. The other thing that you'll note is it is using string builders to build up the syntax, which is usually a lot more maintainable. You will note that the fact that I'm building up a string sort of ties me into a particular language. So if you want to add in, say, VB support or similar, that's something additional that needs to be added. But we can do that. I have a slightly different generator we can look at for doing that one. So I am in the wrong one. I don't want to be in execute. I want to be in initialize. Test Explorer, get out of my way. Okay, so I'm going to just shamefully poach from my other project because that's what we do. Okay, so we'll do that, and then we need a syntax receiver, which is going to look something akin to this. Go like this, and then implement interface. Okay, so what this ends up doing, because you can imagine when we talk about the AST or the Roslyn syntax tree, there's a lot of nodes in there. And in fact, the documentation page, where was they not show it in here? I think there was syntax analysis. They have a great picture in here. Yeah. So there's a section in here about understanding syntax trees. So if you want to understand when you write some code, in this case, when you write hello world, what does the syntax tree of this C# code look like in terms of what the compiler is going to see? It looks kind of like this. And as you can imagine, that's a lot of stuff. And we could write some like link queries or whatnot to go through and deal with it, but that's a lot of stuff. And I don't want to deal with that. That's way too much stuff. So what you can do instead is what's called a visitor pattern, where something else walks through the tree and just invokes your visitor at each step of the way. That is effectively what this little guy here is going to do for us, because he will go visiting, and then we can just inside of here, because on this context, what is it? Context node. It will go and report back to us all of the nodes that it visited on its little journey, and you can kind of see all the different things in here, and we can tell it what kind of things we're interested in. Simple enough. So let's go with, let's see, if context node is, and then it'll be something syntax. So class syntax or type syntax. And maybe it's easiest if we just go and grab, I think I actually have this syntax visualizer. Do I still have this installed? At one point in time I installed. Not. Let's go and grab this guy real quick, because this is probably useful. Yeah, I get that. Syntax tree, syntax node, blah, blah, blah. Where is the, I thought it included Visual Studio Extension Development. It's under View, I believe. Thank you, Casey. What is it called? I would have expected it under Server Explorer. I might not have it Other windows. Code data. Telecode document outline. I don't think I have it. Okay. I must have blown stuff away when I redid my machine. Okay, come here real quick. Let's do this. Close some stuff down, specifically Visual Studio, and then it is the extension development. Visual Studio extension development. Oh, look at that. Let's see, individual components. I'm going to assume it's one of those. Do the needful. And we should save and shut down real quick. Okay, because I think we're going to want to look at this syntax tree. The other thing is I believe Sharp Labs has it as well, if I'm not mistaken. Syntax tree. Show me the syntax. So, for people who haven't seen sharplab.io, a very worthwhile tool. Assuming it's going to launch. Are we gonna? Are you gonna load? Hello. I often use this to check like IL related stuff for boxing. There we go. Syntax tree. Show it to me. There we are. See, that's what we're going for. See, this is what we want. This is what we want. Okay. Save your workflow. Sure. SSH agent is apparently running. Have at it. So we can grab this guy here, and we can imagine that this is going to look like something like public class, controller tests, and then this is going to be something like test method. And you'll note, even though I don't have any using statement for this, the syntax tree still is able to parse. So anything that's valid C# syntax, the syntax tree can figure out what it is, even if it doesn't know how to resolve this to a particular type. You can see it gets all the way down, attribute list. So in order to pull the test thing, it's going to look, so I guess in our case, what we're going to have is something more like this, where it is AutoMocker gen test type of my type. So in our case, we are looking for a class declaration and then pull off the attribute list off of that class definition. We will be looking for an attribute that has a name that matches whatever identifier we give it. And then inside of that, we will be looking for an argument list to pull open the little type of guy. Seems simple? Okay. All that work to install it, and we may end up just sticking with this because this is rather convenient. I will say I do love SharpLab. The other nice part is SharpLab, as you can see, updates quite consistently, especially with like feature branches. So if there is a preview feature you want to play with and try, you can get in there and test them. Just realized and remembered why I moved away from the syntax receiver. Why is that, Casey? Painful? Difficult? And I already forgot my type that I was targeting. I am looking for class declaration. Oh, okay. Build your things. Have fun. Go hunting. What is the type? Because this is going to be, we can go hunting it by fully qualified namespace. Qualified. Let's see, C#, and then it'll be syntax, and then it'll be analysis of the project running the analyzer. Oh, does yours not need to look at the syntax tree, and instead you need to look at the project? Analysis of a project outside of the project running the analyzer. Ah, you want to look into something more interesting. Okay. So, if what Casey's talking about sounds interesting, I've conned him into working on it with me. Probably on my stream. Probably soon. Right? Class declaration. Okay, so we'll start here. We want to find a thing that's a class declaration, and then let's do this, and because we can actually output errors and whatnot. So we're gonna come in here for this syntax receiver, and we're gonna just do put you in your own file for a moment. Okay, so we want to look for if it is partial or not. So let's see, how do we do that? Check. So partial. So where does that end up showing up? So under the, so it's underneath the class partial keyword. Okay, so I'm looking for a partial keyword underneath the class declaration. Okay. Class declaration, something about partial. How do I find your modifiers? It's the modifier list. I have a sinking suspicion it looks like this. Syntax token list. Okay, so lesson 1, debugging a source generator. These things are notoriously a pain in the butt to debug, because in order to debug, you actually have to attach yourself to the compiler while it's compiling. So if you can put yourself in the inception mindset, that's what's actually going to happen here, is we are going to attach ourselves to it. And the easiest way is with a debugger launch. So, and actually, before I get too carried away, live unit testing needs to stop running. Okay, so I'm going to do this in a very particular order. I'm going to rebuild my source generator project, and then I'm going to rebuild the project that is using it. Keywords I hit rebuild, not build, because unfortunately, MS Build tries to be intelligent about what's changed, and it won't see any changed files, at least in the project being built. Rebuild forces it to always run. Okay, so it launched, it hit that debugger launch, and we're going to attach with ourselves, to ourselves, which is exciting. Okay, so we hit our debugger launch, and inside of here, I'm going to just put a breakpoint on this, and we'll just see it. We'll watch this thing get hit. So we're going to see this guy get hit a ton. So node, and I think I can do node, there's kind is probably good enough. Pin. Where did that pin go? Pin. There, stay there. Okay, so we'll just F5 this a couple times, and you'll note, so okay, so now we hit a using directive syntax, qualified name syntax, and we can just keep hitting a bunch of these breakpoints. We're gonna F5. Okay, so we got down to our class declaration syntax. We can see because there's only one class in this project, it's gonna be ours, which it is. Huzzah. Okay, let's go a little spelunking through this guy to figure out where this thing lives, because I think it was going to be the modifiers, which it appears to be. Oh, this is an IEnumerable visualizer. Got it. Okay. Not nearly as cool and not nearly as scrollable as one would hope. Okay, but it does show that partial is one of the options in here. So inside of the modifiers collection, there is public and partial. If I expand out the enumerable, I can go hunting for the partial keyword. So to know if it's partial, I can just look at modifiers and say, is partial keyword in the modifiers? So if class declaration modifiers of type partial keyword. I think that was right. Using system link. Go here. Oh, come on, don't laugh at me. That was what it was, right? Syntax token partial keyword. What is your type? Am I stupid? What is the actual type of this thing? So immediate window, we're just gonna do some code. Class declaration modifiers. Select x dot get type full name to array. Show me the names of those things. Ah, okay. So they're going to be syntax tokens. Okay. So actually, I think that thing is already going to give me back syntax tokens. So let's go any lambda. And this is going to be, so if they're both syntax tokens, what is the thing inside of it that lets it be syntax token? Something in here knows that it's a partial keyword. Structured trivia. Text, value text. I really would like to not go against that if I can. And something about this thing knows what it is. I think its value, as ugly as that is, that will work. I'm just trying to avoid, because something here knows that it's partial keyword. I want to know what this partial keyword thing is. And I token. Okay, I kind of want to hang on. We're gonna do this. I kind of want to just go grepping through this thing real quick because I'm pretty sure syntax show only classes, show only enums. Syntax kind. Is that a thing? Is there a kind on here that's giving it that? Raw kind. Oh, please no. Please no. Has structured trivia, has trailing trivia. I'm technically looking at public. Magic numbers much better than magic strings. Yes, but those magic numbers I'm pretty sure are... So syntax. I'm pretty confident if I look here. Ha! Ha! Gotcha. Gotcha. X dot. Okay, stop. Okay, you are confused. Go away. X dot raw kind equals the int value of syntax kind. Come on, it's right there. I probably just need this using. I will get you if I need to. Boom. Using syntax kind partial keyword. Ha 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 ha. Okay. So we'll probably end up putting these ifs together with just an and on there for now. Use is kind. Oh, look at that. Okay. Sweet. There's an extension method for it. Perfect. Okay. Okay, so we're only hunting classes. We're only hunting partial. It's probably good enough, I think. I think that's probably good enough for now. So let's figure out the model that we're going to build up, because really right now what we need is... Okay, we're going to make some assumptions. The target type is only going to have a single constructor for the moment, because I don't want to think about multiple constructors. So we need to have public class, test class, and it needs to be public. I'm going to put an object, test class type, right? Public object subtype, so system under test. We're just going to go with that for the moment. And so if we go class declaration, let's see, identifier. Let's go with class declaration dot what is the resolve the type? Because there is a way to get this thing to resolve the type as part of this, because I want to make sure I get this. I think I end up doing this in my XAML test one. Let me look. Let's see, bring it in. Don't laugh at me. This guy, that's the incantation. Because we want to resolve the... We no longer want to look at just text-based tokens. We actually want to get the actual compiler resolve type. Get type info. Okay, let's make sure this is going to work with the way we expect. Paste, run. Let's see. Var foo gets paste, because... Oh, hush. There. So foo dot... What is on this type info? Info dot type, I believe. Oh, interesting. So that's... Oh, type null. So that's not going to quite do what I want. I must have to feed it something off of the end of this. So let's just look at this. Class, full span, English, parent, raw kind. There is a way to resolve this. Type expression syntax, class declaration syntax. I think I've probably gotten it to the point where it is utterly confused. I'm going to restart this guy real quick. We're going to just catch it inside of here again. So once again, rebuild source generator. Oh, this guy is unhappy because I made them non-nullable, so it won't compile. And test class is probably a little ambiguous. Generator target class. Sure, we'll go with that for the moment. Get you out of here. Okay, so rebuild this guy. Great. Rebuild target. Once again, we get the lovely just-in-time debugger. We'll use ourselves to attach to ourselves. We'll F5 in. I want to look at this. Did you fail to resolve the type again? You did. Okay, so how do I know your actual type? That's your attributes. Kind, class declaration, that's great. Modifiers. I'm actually missing where it is. Identifier. What is this guy expected to take in? Download source. Let's see. So it's expected to take in a syntax node and find the type info. I really just want to pull the type info to make sure I know what the type is. So we got to figure out one of these guys needs to give us type info for it. Let's come down here. What are you trying to get the type of? I want to get the type of the class specifically is what I'm looking for. And I'm not entirely sure what the appropriate parameter is here off of the class declaration. Pass in, is it? Syntax token to syntax node. I realize that. I mean, because I can go context.node, but that's the same instance. Yeah, and it's not resolving the type. Despite the fact that it should know. Because ultimately, when I go to generate this thing out, I'm going to need to make sure that my partial class that I generate technically is also going to need to have something like, so the file we generate is going to need to have that right at the top as well. And I probably will generate it with older syntax, more like this, just to be clear of what we're doing. Believe that's what I want. But so the type info that comes back gives you all of that lovely stuff. And I do not see how to grab it. Let's see. Because this guy goes in here. I'm just looking at what I did on my other source generator as well. Try casting the node to a class declaration syntax. Kind of like this. And then pass it into there. It's kind of what I expected to do, but for whatever reason, this thing is not finding it. And I don't entirely know why. Let's see. So let's go with I'm wondering if it's actually the parent. No? Because it still wants a syntax, even though that thing is there. File scope namespace declaration syntax. Class declaration, get type. I'm a little hesitant to think. Well, so class declaration get type isn't going to quite get me what I want. So if I go get type, this is the actual method on system object. So this is going to give me something that's, Microsoft code analysis fit. And what I'm looking to get is something that contains namespace here of controller tests, which is going to be the thing that trips me up. Let me look at this guy. What was... Oh, that's right. He wasn't inspecting. He was just generating. Cheater. If I look here, it's in here. Because in this one here, I end up doing something very similar, where I pull it off of the, in this case, the type argument type, which is why I was expecting to find class declaration with some sort of type thingy on here, but there's... Let's investigate this guy. So what does he have on... let's just do watch window. Hey. Don't have any of them open? How about locals? Come on, go find it. Any day now. Visual Studio. Really? Still can't find it. Okay, you are worthless. Windows locals. Was that really that hard? Is that really that hard, Visual Studio? See? Not hard. Not hard. Okay, we're gonna go Splunky. Syntax token, class, keyword, kind, text. Raw kind, blah, blah, blah. Semicolon token. Okay, so when in doubt, the all-powerful being of Google knows. So let's see. Roslyn, class, declaration, syntax, type info. Yeah, how about get type info? Boom. What do we got here? So syntactic model, blah, 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 blah. The namespace is syntactic information, so you need to get it from the semantic model. Model, get type info, CL. So what was his CL up here? Project, documents, classes. Not helpful. Boom, boom, boom. Initialize, register. Syntax node, finding well-known types. Yep, finding other types. We could do it from there, but I'd kind of like to resolve it not from just a string, but from something known. Find generic types. Get type of a syntax node. Context, semantic model, get type info node. Stop. That is legitimately exactly what I'm doing. What the heck? Yep, that's kind of what I thought I was doing. Class declaration syntax. Syntax node helper, out namespace. I get parent syntax. So this thing just walks up the parent syntax, looking for a syntax node that matches a particular type. This is literally just walking up looking for the namespace type. That's fine. That's not what I want. Parent is kind, syntax kind, class declaration. Items. Oh, actually, this is an interesting point. I don't need it, per se. I can gen without it. Because what we can do is we can go public string nullable namespace, right? Get set. And then what we can do is we can just do class name. Because we know something already about this, specifically that we are inside of a test project and we are looking for a test class, and I'm going to be generating alongside. Okay, so that we can do this differently. Okay, so string test class name gets class declaration identifier value. I just want text. Do that. And then what we can do is we can find the find namespace, and we can do the same thing where we go walking up and go ancestors. And then we can go of type namespace declaration syntax. First to do nested namespaces. They're uncommon, but they are legit. Actually, we could do this. I guess this isn't bad, right? So theoretically, the nested, you were looking for the name. Well, I'm looking for both the class name and the namespace. The name I can figure out, but I was hoping to pull the type info and get the fully qualified name. Yeah, and parent we can use because we'll go ancestors up. But the only thing I'm somewhat interested in is, right, so I can do. So this is new syntax, but technically, this is the problem with source generators, is if you're inspecting code, you have to look at all of them. This is actually valid code as well. Now, very few people do this. Yeah, I think I'm going to use ancestors, though, rather than just going against parent. Because this way I can pick them all up. So, and actually, we can handle nested namespaces right now. Or each. Let's see. Var namespace in. Disambiguate the keyword. Totally forgot about nested namespaces. That's because no one uses them. The only thing that bothers me is there's a lot of consumers of this library, and I can just about guarantee there's going to be somebody where this breaks their use case. Because it would be nested namespaces for the unit test class. Yuck. Okay. String namespace declaration gets empty string. And then what we will do is we will do namespace declaration gets, let's see, namespace dot identifier. What is the magical thing on this guy? Yeah, download source. Yeah, I kind of just want the name. Oh, it's called name. Well, who would have expected it to be that? Identifier text get text. Nope, that's the source text for it, which would work. Oh, fully including its leading and trailing trivia. That's probably good enough. We're gonna do something mildly clever. Private static enumerable of strings get namespaces. Class declaration syntax, class declaration. And then if we do this, because I don't want to deal with figuring out how to put things together. So I'm gonna cheat. Yield return. And I'm going to cheat a little bit more because right now this is starting at the bottom and walking up because we're using ancestors. And ultimately, if I'm going to join them together with periods, I want them backwards. So we're going to just reverse that. Yield return those things back out. Get namespaces. Boom. No thinking. Done. Okay, so that gets me that far. That gets me that far. That gets me that far. Okay, so let's get this syntax receiver kicking back data and get the thing generating at least the empty class for me. So the magical syntaxy thing here, this guy is going to need something to share. How did I pull the data back off of him? Syntax receiver, that magic syntax. Got it. So we are going to go with public list, what was it? Generator target class, test classes. Get, instantiate new, test classes, add new, generator target class. Really should clean this up at some point. Namespace gets namespace declaration, test class name. Oh, IntelliCode, you are on point today. Love it. Love it, love it, love it. Okay, come up here, pull the syntax receiver back off of that guy, and now we've got it. So, and then we will iterate over our test classes. Our test class in. Okay. Use explicit type. Don't make it knowable. Okay, so given a test class and wanting to generate this, ultimately we'll need to do more advanced stuff, but this is kind of what we're looking to do. So we are going to do, I think we're going to do a separate, I'm going to go the string builder approach. And several people have written like indented string builders too. I'm just going to paste this here as an example of what we're going for. So builder append line. We're going to need namespace, and then this is going to end up being namespace of test class namespace. And then we're going to add in, because I'm going to do this, the generator guy is going to do old school namespaces. Just because if I don't and somebody tries to use this elsewhere, the world will fall apart. And then we will do builder, append line, partial class, and then this will be test class name. Boom. Boom. Open, close brace. Okay, and that gets me into there. And then for now, we're going to make the sweeping assumption that we're MS test. So to do detect other test frameworks. So we'll need to do that at some point, but we'll leave that in. And then we're going to do this because we are, let's see, builder append line. Okay, so the next thing we need to do is we need to rip through the types constructors. You need to match the accessibility of the analyzed class that you are generating the partial floor. Ah, good question. So in this case, I'm going to cheat. So you only have to match the accessibility modifier if you specify one. So in my case, I'm going to generate it without one, and then I don't. Because you can only have one access modifier ever specified. So as long as it's only specified on one of the partials, you're good. There's only one. If you specify the same one on all partials, you're also good. The moment you do something different, now you've got a problem. So we're going to cheat and just omit it. So abuse the syntax a little bit. Not that I would ever do that. Okay, I am realizing though we are going to need to get that type because at some point I'm going to have to find that type's constructors, which is going to be interesting. Okay, but we're gonna get this much working. So this will be, and we may offer some configuration options at some point. Test class. Yeah, I do that sometimes, don't I? Oh, this isn't test class name. This is going to be, okay, so we're going to need to, so public class subclass, public, and so this thing is going to need to have a public string name, right? Because we're going to need to know its name. And then he's also going to need to have constructors or constructor parameters. So let's do this. Public class null constructor test. Constructor parameter test. And this guy will contain a list of these. Constructor null. Yeah, so we'll just do that. Okay, so we'll do that, and this guy here. So this will end up then for eaching over each of those, right? So this guy here is going to need so let's see here. So before we get to this, inside of this, the for each actually needs to live above this because we're going to for each of the tests. So for each test, for each bar test in test class set parameter test. Okay, so dereference a possibly null value, blah. And that thing. Okay. That'll be fine. And then this moves up in here too. So for each of the tests, we're going to generate this. This is actually going to be test dot. I guess it's actually sut name, isn't it? Test class sut dot name. And you can't be null if we get to this point. With null, and then this is going to have to be so this thing here is going to need to have public string null type short name. This is going to need to have, we're going to want the, actually null, we're not going to do type name, we're going to do full name and name. Oh, it kind of lines up with the naming of yeah, that way it sort of lines up with the naming of the reflection APIs. Okay, so then builder append line, boom, do that, do that, do that, and 1 2 3 4 5 6 7 8 8, good. 1 2 3 4 5 6 7 8. Okay, that, I try to do my indentation to make it pretty. Okay, so that should generate up this. Now we need to make sure that our syntax receiver is actually populating those. Let's see. Sut gets new sut class name gets, and in this case we are just going to call it controller. We'll assume we parse the rest of that out. New, and actually we can do this. So fun trick. You'll note I just did a equals and then open curly brace. So that is the cheater way to go about adding items to an existing list. So because this property is a read-only property, normally you shouldn't be able to assign to it. But yet I'm doing an assignment. It's really not an assignment. The compiler is hip to the idea to know, oh, okay, I get what you mean. You want to call add repeatedly using these items inside of here. So, okay, so we're going to assume we can figure these out at some point. But for now, we're just going to get this guy generating and make sure that it works. Okay, so controller, null type name. We're gonna just hard code some of these values in for the moment just to make it work and get the generator going, and then we'll come back and figure out how to parse that data once we get rolling. So we will need these lines next. So those are going to go there. Let's just do this. Builder end line. That maneuver. This is probably going to need to be fully qualified. I'm going to do this. Now I'm going to generate it with older C# syntax just so that it doesn't... Oh, hush. I understand you're unhappy. Just so that if people are using it differently, and then this will be interesting. So generated code by default doesn't have nullable reference types turned on. Okay, so just be aware of that. It is nullable ambiguous or nullable unknown. I don't remember the exact name of it. Okay, so this one here is going to be slightly different in that this is going to need type of, and this will be test null type And I want this to be full name, because I want this to be fully qualified. And then this is going to be system dot, and this will be system dot, and we'll just populate that. And then this will be set name. So this will be here, test class set full name. $sign there. Let's see, close quote, close paren. We'll need to add a full name property there. And then this is just going to be, we will need this to be test parameter name. I need to add some properties there, and then that should work. Okay, so why did you not figure it out? Null type full name. We're going to go name, full name, and then set full name. Boom. That, and then test needs parameter name on it. That'll get me into there, that'll get me into there, that will get me into there. Okay, so that's all well and good. Syntax receiver. Okay, so let's see. Null type full name is going to get I don't remember the full name of this guy. Big. This thing. This is what it ultimately needs to find, because it needs to look this up from the constructor. Parameter name, service. And then this needs to be full name here. And I believe it's going to have the same thingy-mabobber there. And that's what it's going to generate. Okay. Let's try it. Oh, not going to work yet because we didn't actually do anything with the code that we generated. So we built this up, did all this work, and then we need to add it, because if you just build up the code into a string builder, that's great, except for then it's just in a string builder. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There. And then to add it is context, add source, and we do need to give it a name. And then the final parameter will be builder to string. So this is going to be test class. So how about I'm trying to think if I can get away with test class. This is probably not going to be sufficient to do something so simplistic like this, but we're gonna start here. Test class, test name .g.cs. Okay, and then there's one more thing I want to set up on this guy, because if I go back to my nose plug library, there's a clever trick for debugging the output of these things, because this will not it will not show you the output by default. But normally these files just get tacked on there. Where did I put it? In my directory build props. This magical thing. emit compiler generated files. So with this off, it just compiles fast. With this on, it will actually generate some C# files we can go look at. So that is another easy way. This is another way to debug your source generators. So we're going to turn this guy off, rebuild him. And then we'll rebuild this. So hopefully, assuming our thing doesn't blow up, test method attribute could not be found. Huh? What did I do wrong? So I am noticing that this is in my generated file, test method attribute. Oh, because I did this and didn't add in a using statement to it. Okay, so we're gonna just fully qualify. I tend to prefer fully qualifying these things. And then we'll try again. Actually, real quick, before we try again, I will show you where those files go. So if you look at your project folder, so this is the unit test project that has it added. Underneath OBJ and then target, in my case, or configuration, in my case debug, generated here, and you'll note there's the C# file that we built. So I can see another problem that I'm going to run into right away is apparently I didn't specify a namespace. So that's a problem. Which is interesting since I thought our syntax receiver was retrieving that. But you know what? In the interest of simplicity, we're going to hard code it. Just be this for now. Come back and parse that out in a moment. So we have to rebuild our source generator because we modified it. And then we have to recompile this guy here. Okay, and now it's running into duplicate member, which is what we want. So we are going to get rid of this guy, because hopefully that is gone now. And rebuild one more time. And hopefully we have a test. Assert isn't found, because once again, I did not fully qualify it. Let's see here. So let's do... And I may go back on this and not fully qualify everything and slap some using statements in here, but for now we're going to fully qualify. Fully qualify just has the nice perk of I'm less concerned about naming collisions when that happens. It's probably pretty unlikely. I'm generating all the code. Like, it's going to be something like somebody has their own assert class or similar, but it's like, I don't want an ambiguous type match. Okay, so it rebuilt, which is a plus. If we look back here at our generated stuff, we can see what we got. Looks pretty good. So you'll note here we're all commented out. But if I right click here and hit run tests, I should get a test in here. I got a test. And you'll note the slightly unfortunate part is no source available, because this was an auto-generated deal. However, it's named pretty explicitly, and we can go and look at it in the generated file if we want to take a look at what it's doing. Which is pretty good. Okay. That gets me most of the way. At least for the first bit. I still have to figure out how to populate these things here. Now, the one other thing I wanted to look at is on here. I want to see if I can detect the referenced assemblies. So I don't think I do that here. I think I get that up here. because I want to know the referenced assemblies to this guy. I think it's under compilation, like assemblies or references. Referenced assembly names. Got it. This is what I want. This is what I want. Pretty sure. Pretty sure. Because I think we can leverage this to say, hey, what does it look like? So we are going to create our own public enum testing framework. Or how about target testing framework? We'll start with an unknown, which will be our generic case. MS test, X unit, N unit. Okay. Then we'll write a quick method here. Private static. Boom. Get testing framework. Boom. And you're going to take in the, I think we can probably limit it of what it needs. So context, compilation, referenced assembly names. I think we can just feed it one of these thingies. Yeah. Just go. Remember my selection, please. So I want it to take in one of these thingies and just rip through it and say assemblies. Okay, so if, what do we got here? We got a dependency. Let's go with so we'll just rip through there. For each assembly identity, assembly in assemblies, assembly dot, oh, culture name. That's interesting. Get display name. I think I just kind of want to go with name. Contains Microsoft Net Test SDK. Return target testing framework, MS test. And then at the very end of this, return target testing framework unknown. And we might, again, this is one of those cases where I could very conceivably go through and add in a configuration option to override this in case its guessing is wrong. We can probably get pretty close. Ooh, we can't rely on that particular one, can't we? So how about name starts with MS test? Starts with MS test dot. And then name starts with N unit. Yeah, we'll go with that. And then I wonder if I should target the test adapter one specifically. No, because that doesn't have it. Starts with X unit. This will be N unit, X unit. Okay. So if that works, so we're going to come down here. Testing framework. Something like that, something like that. Okay, And then down here, we're going to just do switch testing framework and case testing framework ms test. Tack this in. Just start adding in these other ones. X unit. Obviously that's wrong, but we will fix it in a minute. Case. N unit. And paste that in. Okay, so let's go get those ones. Those ones all have them. So N unit's thing is NUnit framework.test. That's easy enough to do. NUnit framework test. And then X unit is fact. I think it's just xunit.fact. So that's also easy enough to do. Get rid of you. Don't need you anymore. Boom, boom, boom. Fact, right, is what we said it was. Where's the X unit one? Capital X, lowercase u. I'm wondering if I should do that for... Probably do that down here for this guy as well. So we'll change him. Capital X, lowercase u. Looks a little funny, but we'll go with it. That's what they do for their namespace, so it can't be that bad. Okay, so that gets me into there. The rest of that remains the same. That remains the same. Okay, and then this becomes the interesting line. So these two are going to be different, depending on the target framework as well. So we will put in the same switch. Copy, paste. And then in this case, we're going to go here. And if it's not clear, the goal here in just a second is to turn this on for all of the tests. And then this will go here. Okay, so for, let's do X unit, I guess, since we got this highlighted. So it's X unit dot assert, and I think most everything else remains the same. This is just going to be, X unit dot assert, and this becomes, well, this is just throws, not throws exception. Dumb you down a little bit, but the rest of it's just about the same. That works. Okay, N unit. And this is going to be insert throws. Okay, insert R equals, so N unit framework. N unit framework. So I just need that prefix on both of those asserts. So that goes there. That lines up. This one goes here, and this one is also just throws. Okay, so I think that's everything needed to get that working for the other two test projects. So let's go turn them on. So like we did before, we're going to add in project reference. So N unit, we'll add in the analyzer. Boom, boom, boom. X unit, we will add in there. It's popping a weird JIT debugger thing. See what's going on there. Rebuild. Just make sure I have that thing turned off. It shouldn't be popping it. Okay, so that goes there, that goes there, and then just like we had the emit turned on the one, turn the emit on the others. Okay, now we'll rebuild MS test, verify it works. compiled, so it couldn't be that bad. Rebuild end unit. And one other thing to note is underneath this analyzer, you'll note that our thing shows up. You can also get a view of your source code down here as well. But that doesn't appear to be showing it. We'll find out why here in a moment. Let's see, X unit failed for some reason. Let's look at the output here. Unable to test classes must be public. Oh, am I not generating these classes as public? Probably should be if I'm not. Source generator. So partial class. That seems to imply that the name of this. Oh, it's generating into a different namespace. Oh. So the partial that's being generated has a hard-coded namespace, which is a problem. Okay, so we need to solve that one before we're going to get too much further, because X unit's happy about it, or X unit's unhappy about it, and rightfully so. So let's figure out what's going on there. We're going to come back in here, turn this on, rebuild the generator. We're going to come here. Yeah, breakpoint's still set. We're going to rebuild X unit. I'm a little curious why okay. The namespace is empty string. Okay, great. So let's go into here. So class declaration ancestors of type return nothing. Let's go here and take a look at class declaration ancestors to list. What just happened? Okay, so that's too much stuff to look at. And the how about just a straight count? 2. So to list var a gets, evaluate that, a sub 0 is what? Let's see, file scope namespace declaration. Ah, ha, 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 ha. Got it. So that is a bit of a problem, because file scope namespace declaration syntax is apparently not a namespace declaration syntax. We probably want to target base namespace declaration syntax as the. I'm going to go with you both probably derive from base. Not immediately apparent. Yeah, base namespace declaration syntax. So we want to target this. That's why it's falling apart. We want that. Okay. And now if we rebuild the source generator, and then we can probably put this guy back to namespace declaration, but we're going to check it here real quick and make sure it actually does work. And then rebuild you. Pop my debugger, please. Thank you. Thank you. Namespace declaration is now correct. Excellent. 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 Okay, so we're going to go back into here. Turn you off. Okay, so now we're running into the duplicate test name problem, which is as we expect. So let's comment out these tests. Comment out these tests. Stop. And then we are going to rebuild that guy, and then I want to rebuild each of these and see my tests work. So rebuild. And rebuild. And rebuild. Okay. So I messed up on one of these. Let's see, which project am I in? XUnit. Oh, it's just assert equals, right? Yeah, assert equal. So I need to change the generator for the XUnit case to assert equal. Rebuild the generator. Rebuild XUnit. Okay, so they're all compiled. We come over here. This thing's probably about to freak out for a moment. There's the generated test for XUnit. So if we run that, that should show up. Great. And I should be able to do the same thing for NUnit, rebuild. Why are you not showing in here? Same with MS test. Rebuild. I'm wondering if this guy is not hip to the idea of it's getting confused with multiple test runners all being loaded at once. Let's see, run tests. The MS test one doesn't appear to want to run. Run tests. Can I run all? Where's the run test? There. Target and assembly. Okay. Feeling like this is so it found the XUnit one. What worries me is I'm wondering if the XUnit one is somehow hijacking this guy, the test discovery. I would hope that you could do this, but I've honestly never tried to have multiple test frameworks in the same solution. Have Visual Studio handle it. It's also possible that the code generation on these other ones isn't working. So let's go back to start with MS Test, because this one was working and was generating appropriately. So we're going to look at the generated file first of all. Chase it all the way in. So this one ended up not. So I'm noticing the attributes missing and everything else. So this thing did not discover MS Test. Is there a difference between the assembly name and I wonder if there's a subtle I bet you it's this Microsoft Visual Studio Test Platform. So let's start there. I bet you there's a difference between the NuGet package name and the in the compiled assembly. So that's fine. We can come down here. We can change this in one sweep of our hands. Microsoft Visual Studio Test Platform. We'll start there. Rebuild this. And then rebuild this. And now I'm wondering if it shows up. Because we had it working before we put in that target test framework. And I'm wondering if that's what messed it up. Ha 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 ha! That it did. That it did. Okay, so that got MS Test back in and working. Great. Okay, let's do NUnit. Why are you unhappy now? Let's check for the same exact problem. If there is a... Oh, NUnit dot. I wonder if XUnit is going to be an XUnit dot that we can do as well. Yeah, XUnit dot. We're going to do that. And then let's see, rebuild the generator. And then we're going to rebuild that. And then rebuild that. Looked like XUnit had a problem. Test tools does not exist. Oh, we're falling into the wrong one now. Because this guy has extra stuff. So I need to look for something a little more hyper specific. What is... What is in here that would separate you? Microsoft Visual Studio Test Platform. Test Framework. Narrow it down even further because it does include a little... Yeah, because it does leverage all of these ones here. I'm not overly shocked that that landed in the wrong one. A rebuild NUnit. You happy? Framework does not exist inside of... Sounds like it landed on the wrong thing. Take a look. Where is the generated code? So let's go. Are you going to actually show me the source generator? No, you're not going to be useful. Okay, that's fine. You can be unuseful today. It's really nice when it works, really kind of obnoxious when it doesn't. So let's go back in here, here. It did detect it as NUnit correctly. What was your problem here? Let's see, line 5, NUnit framework.test. That not the right... NUnit framework.test. You can also try seeing the generated code in the class view, I believe. Oh, rather than the solution one. No, not here. Let's see. So if we'll dock this guy on that side, let's take a look. So if I go NUnit controller test. Well, right now it's failing to compile, so that's probably a bad example, but let's go in here. No. Let me get it compiling and then I'll double check. But I think you might be right. I always forget about the class view. It is a very useful tool and often underrated. Okay, so we were going here. In unit framework.test. Actually, here's what we're going to do. We're going to literally just copy and paste you out. What did I do wrong? I didn't find out about the SLN way of seeing the generated files till today. Yeah, and I oftentimes actually like, you can see how I've opened it here, because Visual Studio, if you just drag in a random C# file, if that file updates on disk, it'll update here as well, even on compilation failure. Like I've noticed a lot of the generator tooling fails on compilation failure, which is the exact time when I really want to look at it. It's like, I would like to go and see it when it fails. That's like the most likely time I want to go look at it. So oftentimes I'll just leave this open. Framework does not exist in the namespace. Forgive me for questioning you, but what? So conveniently I'm getting the same error, but I don't understand why. Turn you off for a moment. Turn you off for a moment. Okay, so we got that figured out. Oh. Suck. Yuck. Okay, so here's a fun C# problem. Okay, this compiles, this doesn't, despite the fact that this is a fully qualified name. And this is part of why I was like, oh, I could add the using statements into my generator file. Oh, but that could run into weird collisions. Yes, like this. And even without doing it, it ran into weird collisions. So there is a concept of, so there are 3 levels to specifying an identifier in C#. There's the name, there's the fully qualified name, and then there's the assembly qualified name. Each working their way up the hierarchy. In this case, because I have a namespace in this project that's NUnit, it is trying to go relative to this NUnit, do .framework, and find the test attribute, which it's obviously not going to find. But once I tell it, no, this isn't relative, start from the global namespace, and this is the fully qualified name, then it finds it. Oh, that is dumb. That dumb. Okay, we're gonna massively qualify some stuff. We're gonna massively qualify this beast. Okay. Yes, gross is the appropriate response to that. We are going to fully qualify all of those while we're in here. Fully qualify that, fully qualify that. Like, this is generated code. It's once it's working, ideally no one has to look at it. But that will ensure that it is not, that if you put that hypothetically, if you do something dumb like me and put an NUnit namespace in your test project, it doesn't break, which isn't terribly uncommon. Like, I'll create like an NUnit or an XUnit namespace in my test project if I'm like writing extension methods to extend the test framework, right? That's kind of a normal thing. XUnit is built to be extendable. Like, so some of the projects I work on, I've built some extensions for them. That's great. They work. It's wonderful. Okay. And then rebuild. Okay, so they all compile. Okay, they all compile. Test Explorer, find them all. Pretty please. Now that they all exist, please go hunting them. Because I'd like them all to run next. That's your next task. Come on, what are you doing? Aborting test discovery because build was performed. Build solution. Okay, everything's built. What's your problem, Test Explorer? I'm gonna relaunch you because I'm not trusting you at the moment. I'm pretty sure you are. Oh, that is the other drawback. If you open a generated file from the Analyzers tab, you currently get this error in Preview Visual Studio. It's really annoying. And it won't go away until you close the tab. It's a great feature. Okay. Test Explorer. Have you just got yourself wrapped around the axle, or are you actually working? I think you're wrapped around the axle. I think it'll be quicker for me if I restart you. We're going to start with that. Boom. And I think it will work. I can't promise anything. Come on. Load. Load. Mountain Dew is empty. I'm trying to decide. It's 11 o'clock. Do I crack into the next one or not? It's really tempting. It's really tempting. Okay. Because I'm clearly not done. I've got a meeting in the morning, but it's not till like 9. That's okay, right? Right? I don't think any of the people in that meeting are watching the stream. So, is this the wrong way to evaluate opening them out? Okay, fine. On a positive note, go! Test pass! Test pass. Okay, we immediately commit. Working generated tests. Let's see. Using lots of hard-coded values for now. Okay, so we've got the tests in and working. We've got it switching based upon the target framework. We might, like I said, we might add a config value at some point that you can specify in your CS proj to override it. If, for example, it's not detecting the right thing because, you know, one of these libraries changes or whatnot. Because we aren't going to ship a version of AutoMocker that takes a hard dependency on any of these testing frameworks. However, if I gen the code, I don't have to take a hard dependency, which is even better, because then the code lives in your project. Okay, so let's see if we can figure out some of these other ones, because we've got the generating of the generation is fine. However, I still need to figure out how to get that type info. Because at the end of the day, the next thing I need to do is investigate the constructor. And with the way we set this up, where this is just doing null constructor parameter tests, I could theoretically handle multiple constructors. I would just have to change up the name. I would have to change the name of the test, because right now it's using, what do we do? The name of the test is based entirely upon the system under test and the null parameter type. So I've already got a problem if you say generate a constructor with 2 I services. That's a problem. So that ain't gonna work. So we're gonna have to disambiguate a little bit, or at least make this thing keep track of what method names it's already used, and not use them again. Like I said, this is another area where I feel like I might add a little bit of configuration in, where if somebody wants to change up the naming scheme used here, you can do so. Like maybe we'll do a simple like token replacement type deal on these, and you can access a few of the members or whatever. That seems like a fun thing to do. Have a little bit of config. We'll ship a default that looks kind of like this. Okay. Okay, so let's figure out why we can't retrieve the type. Why would I not be able to get the type? So, hey, Dituta? Welcome. We are building out a C# source generator to write unit tests because I am that level of lazy. And I hate having to write low-value unit tests. Unfortunately, some companies have rules about you have to have a certain percentage of code coverage, which is fine. I just don't like that as a measurable metric at all. So, with that said, that's what we're trying to do. And specifically, we are trying to figure out... So let's start with some collapsing. So for starters, we've got two if statements back to back with no else in there, which means these things collapse. Right? We can just collapse those things together and... Oh, did it delete the... Oh, it deleted the closing brace for me. Oh, no, it didn't. Because it didn't unindent properly? Yeah, it didn't... Oh. There. There. Okay. I was very surprised. Okay, so... But ultimately, we can't just use this to get it. I just discovered the MVVM source generators. Yes! Depending on which one you're using, so what is it? The Microsoft MVVM. There's a couple of them out there, but the ones from the Microsoft Toolkit are excellent. I don't remember exactly which one of their NuGet packages contains the source generators, but they do have a bunch of them for doing like the iNotify property changed and whatnot in there. Which is, they can be pretty slick. It might be bundled inside the MVVM one. I'd probably have to poke around at it. They can be really good. I try to balance the amount of magic I have in my code, because magic is great as long as everyone understands how it's working. It can also be a recipe for a lot of confusion when the incantation doesn't generate the code that you expect. And it's, what's going on? But yeah, those ones in there can be quite handy. I don't think I've actually shown those off on my stream much. I have a hard time with them because I usually prefer to... I tend to do a lot of extra stuff in my properties where I end up falling away from the auto-generated ones anyway. Yeah, Community Toolkit MVVM. Yep. That sounds right. I believe it's the same repo under the hood that they're all being built out of, because that's the one from... I'm going to butcher the names. Zamel Llama. He streams every so often, and that's one of the projects he enjoys working on. He's one of the key maintainers of it. He can be quite entertaining, by the way, especially if you want to watch some of it. Like, I code and I wear headphones. He codes and wears a llama hat. There's something to be said for the llama. Oh, James Montemagno did one too? I assume the James's one was probably doing it in reference to like either a Xamarin Forms or a Maui app. Because James streams quite a bit too. He is definitely. If people haven't followed, here I'll go find it. We'll go find it. He is a worthwhile one to follow if you don't already on Twitch. Yeah, here, I'll drop his link. Boom. Shout out to James. So definitely a worthwhile one to go through and follow because he does quite a bit of stuff. Source generators in MVVM. Oh, cool. That's pretty cool. I'm guessing his was leveraging source generators, not writing source generators. But I could be wrong. Might have to go and peruse his recent videos. Okay. So, class definition, type info, because we really want an I-type info. Let's see. Because it ended up being context, semantic model, get type info. And I thought this is what should have done it. But let's take a look. So it takes in an attribute syntax, constructor initializer syntax, expression syntax, selector group clause syntax, or regular syntax node. Okay. Okay, so something in this vicinity. Let's ask the Googles real quick again and see what we, because I think we can do get type info, class declaration syntax, semantic model, something. Get type info core. Get declared symbol. Maybe we should try a couple of these options here. S var, because this is going to give me a symbol. Okay, well, let's catch it here and let's put the debugger back on, which is annoying to have to do it this way. And then we will catch it. I don't know. We were playing with MS Test before. Let's stick with what's familiar. They all have the same code though at this point, or actually they all are empty with the same code. Okay, so F5 gets me into here. So type info is still giving me back nothing because type is null. Okay, what is the declared symbol? Ahaha. So name type symbol. Ahaha. This is what I want. Ah. Okay. Because let's look at that. There she be. There she be. Okay, so we're gonna add this in here too because we should be able to retrieve this. So boom is I name type symbol, symbol. Okay. Once we get the symbol, now we can party on this thing, because the symbol likely also has containing namespace, right? Which is going to get us the whole namespace, and everyone's going to be happy, or I'm going to be happy at this point. Okay, so now we don't have to do any of this extra work. Okay. So let's start building this guy up. So for each var constructor in symbol instructors, boom, gimme. Okay, so we're gonna have to build this guy up a little bit, because we're gonna need to make one of these thingies and then start appending things into it. I'm not gonna be able to just do it all at one shot. So let's do this. Boom. Target class gets new. So we should be able to populate those, and we can probably end up populating these straight from the symbol now. And then this. So we can probably even continue here and do this. So let's see. Var. Oh, let's get rid of the var again. And do that. And semicolon. Make you happy. And then this becomes this. And then all we have to do is populate that bit. I'm going to comment this for the moment. And so at the end, test classes add target class. We're good there. We are going to need to figure out how we're going to populate the target type. Because right now, oh, this is the wrong thingy-mabobber. We still need this. But this isn't the thing with the constructors that I want. I need to add something. I need to add something so that I know what the target type is. Because even though this thing is called controller tests, I need to create, say, an attribute or similar that I can put on here to say, for this class, generate me constructor tests for this target type. So I'm thinking this is actually going to look a little bit like this. What does SUT class do? So in this case, so SUT is just standing for system under test, meaning the class that we want to test. So the tests that we're generating look kind of like this. So in this case, the class that is being tested is our controller class, because we're calling the controller's constructor, and we're passing through a null for iService. Now, our controller only has a single parameter. If it had multiple parameters, what it will end up doing is using mocks for the other parameters, null for the service, the iService instance, specifically so that we can trigger this condition of throwing an argument null. So that's all that is doing, is defining what class we're trying to test with these. So, but I think what we do is we do this. We create a constructor test attribute, and we give it a target type. That seems reasonable. So part of me wants to leverage the new C# feature where they've put in generic types on attributes, which is awesome, which is great. The problem is this thing is still targeting some older C# things, and I know not everyone will be able to use it, which makes me sad. So I have to gen it the old way for now. Okay, so this will be a public class constructor s attribute and then we will let's see, move to your own thingy and now you're going to yell at me for all kinds of stuff. So first of all, hush. Okay, so then you declare attribute usage. So we will only allow people to specify this attribute on classes, because that's the only thing we support. And we will not allow multiple. You can only specify once. And we will do public type. What did we call it over here? Target type. Is that a reasonable enough name? Does target type indicate well enough that this is the type to generate tests for? I'm not sold on it. Get set. And then we're going to do a couple constructors. Default one. And we'll do one more. Type. Let's see, initialize property for me. Okay. What is your problem now? I think what we're going to do is just make you nullable, and we'll just handle the null case. We will just handle the null case. Okay, so this guy here, constructor test, you should now work. So this should be Moq. AutoMock. Okay, good. That now resolves. So that's now a thing. So now we just need our source generator to pick that up. So specifically now, this guy is no longer just looking for this. Something else worth noting, when doing source generators, specifically because you're oftentimes writing conditions that are, well, I'm looking for something that matches A, B, and C. The order that you do the condition checks on A, B, and C should be intentional. The cheaper the check, the earlier it should be, because in C#, it will short circuit. If it sees ands and one of these things returns false, it doesn't evaluate the rest. It stops early, which is great. We abuse that liberally here. Getting the declared symbol, going back to the semantic model, is going to be significantly more expensive than, say, a type check. So we do the type checks first. We then do the modifiers. We're going to do all the cheap stuff early and then go into the harder stuff. So let's see, class declaration. And I think what we saw is on Sharp Lab, because we did this here, right? So we are looking for, on the class declaration, there is going to be an attribute list, and that's what we're going to hunt off of. Okay. So something about an attribute list. Great. Any. Stop there. Do you need to gen the attribute class definition in the analyzed assembly? That's a good question. I don't think I need to. And the only rationale is, and actually this guy can go away too. So this attribute and this generator is going to so I'll back up. The source generator could generate the attribute. It kind of depends, because on one hand, if you wanted to say conditionally have the attribute available based on whatever reason, like, hey, I'm only going to generate this attribute if they're referencing NUnit or similar. Hello, National Needle Mouse. Welcome. Then I could see having the source generator generate the attribute. However, in my case, I want the attribute always there, and we're just going to leverage it for the purpose of what classes to target. So it doesn't hurt me to have it in my main assembly, especially since I intend to have this generator go out in the same NuGet package as this assembly. If they were shipping separately, that might be a different concern then. But in my case, I don't intend to ship two separate NuGet packages. One NuGet package, full send. So I don't know if there is a 100% correct answer. I think it depends. I would probably default to not source generating it if you don't have to, but there's plenty of reasons why it might be desirable. So for what it's worth. Okay, so and I want to look at this attribute list because I think what I'm going to want to do, source generator is getting packaged alone. Yeah, and that does depend a lot on what the consumer model is for this. So I think I actually want to change this up here and go with attribute list, because I think this is going to be a first or default check. Test attribute. The other thing that, and I think this is something Casey, you and I will probably run into, is generally in my source generators, you'll note I do no hard references to other assemblies. And I'm sure you're well versed into the reasons as to why is you get all kinds of fun problems with assembly resolution when it's trying to load, which can be quite problematic at times. Okay, so this is a first or default. Okay, so given the attribute, what is on the attribute that I want? I'm going to be looking for probably based on its name. It's probably good enough. Where is... It's going to look at nose plugs one. Because, or actually XAML test is a pretty good one because it hunts the attribute as well. It's just a handful of things. So argument count. Oh, actually, that's probably... In this case, it specifically went after the attribute. In my case, I think I want to be a little more generous. Argument list. Yeah, because I think I'm going to be hunting this in one of two ways. Because this is already pulling the attribute syntax out and then hunting the arguments on it. In this case, I don't think that's quite what I want. I'd like to pull the attribute and hunt it, I think, by identifier. Let's see. Identifier, name. What are you things? Attribute list syntax. I currently depend on a templating engine to assist in the generation of newtsoft.json to read my JSON config files. Yeah. That's going to be fun. That is going to be fun. I think what we want is select many. Because this is a list syntax. What is on the list, I guess? Let's go here. Yeah, so I think we want to select many because these are attribute lists, and under here we want the attributes, and then off of the attributes we want first or default, because we know the compiler is going to prevent it from allowing multiple on there. We want to find an attribute with an identifier or a name. What is name on here? Full span. Where is the? Does this not have something that's like? I mean, I could name syntax. I could two-string it, but I'd much prefer something a little bit cleaner. Get red at 0. Can't say I understand exactly what that is. So simple name. Identifier name syntax. I probably am going to need to upcast this guy a little bit, because I don't think I want to rely on just a two-string or similar, but maybe that's okay. Like many attributes. I mean, I could go down into here and we could do context, semantic model, get type info, right? And we could pass in A, and we could do, actually, this becomes a select. So I want to break this apart. We get the type info for it. That goes there. You just keep daisy chaining, and then this becomes, that's a type info now. So t dot type it's like a fully qualified name, or go through the symbol. Is base type, all interfaces. Declare type, or is extern? Is record, tuple, is type kind. Yeah, we'll do this for the moment. We'll keep it simple, because this is already getting complicated. It's not perfect. Okay, so it'll find something with that, something through there. Let's see if that actually hits. We still have debug on, great. Rebuild source generator. We can comment this back out, otherwise we're going to hit collisions on the test. And then we will rebuild here. And attach debugger. And I might actually want to do on the syntax receiver, I might want to catch it here, just so that I can take a look at these nodes as they come in. So compilation unit, using directive, qualified name, more qualified names, identifier name, file scope namespace, qualified name, identifier. Get me down to the class one. Okay, this is the one we want to look at. Okay, so by step, modifiers, partial. So we got through the second one. Attribute list. I'm not entirely sure if this is going to work. So it's going to select out the attributes. In this case, test class, great. It's going to grab the type info for it. Select it. The type info that it got came back as test class attribute. That's fine. Next set of attributes is ours. Get the type info. The type is constructor test attribute. Constructor test attribute. It matched. Hallelujah. Got the declared symbol. Wow. I kind of assumed that big of an if statement, my world was going to end pretty quick. That actually worked. Okay. Okay, so let's clean some of these up now too, because this guy here has more information than what he's giving me. So I want this guy to give me some information on his stuff. Specifically, I want his type and his containing namespace. So that's probably the one we want to start with. So this is going to become symbol containing namespace dot this is the one where they have overrides, right? On to display string. I believe here you can go with let's see, symbol display format, and there's like, yeah, there we go. Fully qualified, minimally qualified. I think we're going to go fully qualified. I don't know if that's quite what I want, but we're going to try it. All right, it's not going to be happy with me. So keep editing. So it won't let me run the code, but if I come down here to my interactive window, or my immediate window, boom. And you'll note fully qualified does do the global : in front of it to make sure you don't run into problems. So that's great. Okay, so let's get the class name too. Where am I gonna find you at? Instructed from. That looks very possible. Original definition also looks like a good one. Name is not looking good. Original definition is looking pretty good to me. It's redefined a couple times. Yeah, I'm thinking we're going original definition. So this is going to be then, let's see, symbol original definition to display string, symbol for display format, fully qualified, show it to me. That looks great. Test class name. This is where test class name. I guess I should look at where this gets used, because I think test class name before was pretty light. So we might actually want minimally qualified here. Yeah, so that lines up with what we had before, so we'll put that in. Okay, that gets me there. Okay, and then this guy is going to have a bunch of stuff on it. Oh, and we should do a test attribute. Type is not null. Oh, wait, we know the type is not null because this thing matched. We can make that assumption. But what we really want to grab is the argument list off of that. Right? So this guy here, yeah, show me your stuff, because you are going to have some number of properties specified or initializers set on you. Locations, that doesn't count. Where are you? Where are you? Instance constructors. Da, da, da. I'm actually wondering if maybe I want to grab the original attribute. Oh, first time seeing this immediate window console thing. Yeah, so the immediate window is awesome because it lets you evaluate code. So it may not be obvious because of how much I've messed up this code, but this little yellow arrow shows me my current execution pointer. And so you can run code in your immediate window as though it were at that point in your code. So you have access to all your variables that would exist at that point. You can actually do assignments and other things and get yourself into all kinds of invalid states. It's great fun. But it is incredibly powerful. The other one that you have, if you haven't seen it, is the interactive windows. These ones are kind of like the immediate window, except for you don't get the context. So these are just meant for kind of like your quick scratch pad or like a REPL type thing where you can try out different C# code, but you can get a kind of a back and forth interactive methodology to it. So if you're interested, I tend to use both of these things quite a bit. I like the immediate window for kind of just quick testing code to see quick evaluations of what things are going to do. Because the watch windows and whatnot are pretty good, but they don't quite get you exactly what I want in a lot of cases. Okay, so that evaluated the type, but what I actually want is the token from up here. So unfortunately, when I did this select, I threw away part of the data I wanted. So I might have to go back and break that up because I want the type to do the evaluation, but once I confirm the evaluation, I want to go back and look at the individual attributes because I want this argument list. Yeah. So I want the argument list off the attribute at a certain point. Do I actually care? I think what we can do here is we can make this a little more interesting. So we can do something a bit like this. So we can move this guy into, let's see. We can pull this out and do something like this. And then where T is not null, you just do that. And so the else condition here will just be return null. And then that goes like that. So we can still do the test. Return A. And so this is no longer a type. So I've subtly, by doing this, rather than returning the type info, I'm now back to returning the attribute itself, which is a little bit nicer. Yeah, because this will return null. This thing will keep iterating until it finds a not null value, which will indicate that it matched this condition here. But rather than getting the original or the type info, I'll get the original attribute back out of it. Okay, and so then what we want to do is, let's stop debugging here real quick. We can leave the breakpoint there. I'm going to turn this breakpoint off. Let's rebuild, and I want to try this guy one more time. So I think we can get this pulling that type off next. Because we just need to pull the type out of the attribute and then rip through its constructors. Okay, so there's that. Okay, so this guy here, perfect. So now I just need to pull off his argument list. So, because that's where I'm going to get these values here. So I want to do something with test attribute, argument list. In this case, I can just go 0, or I guess. What are you? Why are you being so dumb? Argument list. Arguments. Okay. Okay, so that is going to give me back something a little more useful. So argument list, arguments, and then inside of there, I will get an attribute argument syntax. This is where I want to be. I think this is where I want to be, but I'm actually not. Let me look at the the XAML test one again, because that one, it went to the arguments list, arguments, validated the attribute, and then pull the type of expression off of it. Okay, so that's pretty much what we want to do here. So it's going to look a little bit like that. This will be quick and dirty approach, but I suspect we've got a problem with it. What are you squawking about? Oh, it's because I'm debugging. Argument list may be null here. Yeah. So we could actually go a step further and validate all of these things inside of here. I'm actually realizing this thing is probably a much cheaper call than what we're about to do, so I'm going to move it up here. Make that call go first. Because in here, what we could actually end up doing is then evaluating if this is the appropriate thing. I think what I'm going to do, though, is this is getting to be hairy. I'm going to make a separate method for this. Private, what is A here? Attribute syntax. Private, pool, get, target type? Sure. Attribute syntax. Do something like that. Boom. And then I'm going to just bring this into here. We may not do this whole if. We might just assume the inside of the if already. So if attribute syntax, argument list, arguments count greater than 0. So we do have some arguments. Let's see, we can do that. And attribute syntax, argument list, dot arguments, first or default. Actually, we should probably do an of type first. Of type, because we wanted to hunt the ones that were, we want the expression that are type ofs. Arguments, so we're going to go select x.expression of type, or type of expressions. And then we are going to take the type of expression and we are going to get the type info for it. Oh, I guess once we get the type of expression, we can just return the type. That'll be type syntax. First or default. Type expression or null. We're going to just change the return type of this to be type type of expression. I actually want this to be the type. It's going to be type syntax. Just drop that. Nullable reference type all the things. Return get target type there. That way that stops this from getting out of hand. Let's see, so that'll get the target type syntax. So off-topic question, but would you use SVGs or PNGs for icon button images in your WPF app? Is there a standard? There's not a standard per se. And it depends a little bit. So if it is an image asset where sizing is going to change or scale differently, I would probably go with an SVG. The advantage of a PNG or a bitmap is going to be that you have native support for it. Whereas SVG, WPF kind of predates when SVG was really a thing. So there's not native SVG support inside of WPF. You end up dropping into something like Skia Sharp or similar to get SVG type things in there. So you will find that it is much easier to pull in a bitmap or a PNG because you can just use the bitmap image source or similar to load those guys up, slap them onto an image control, and you're done. Great. And those image controls will scale up and down, but it's the same as if you were to like resize the image in Paint or something, right? You can get pixelation and it doesn't give you those nice, pretty smooth lines and whatnot that you would get with vector-based art. The other option, because SVGs don't have built-in support, that doesn't mean WPF does not have vector support. They do have shoot, I'm blanking on the name. The path that you can use to get vector-based drawing inside of WPF. So, what is it? There are a handful of things that will actually generate them. So depending on where you're getting your icons. So, material design icons. So for example, I'm just going to pick on this one because I know this one. Load me an icon. I don't care which. Just need an icon. Sure, you'll do. Perfect. You'll note here when I have the options, so they will give you some XAML-based options for pulling this in with like a view box and a canvas. But again, it's going to use the path Yeah, PNG will look very blurry on a 4K monitor if its native resolution was for 1080p. It kind of depends on the PNG and how big it was supposed to be in the first place, right? Like, if you are, so WPF, or I should say inside of Windows, there will typically be DPI scaling, because just because you go from a 1080p to a 4K monitor, even though you've got 4 times as many pixels, that doesn't mean things are at 25% their original height. The DPI scales it. So you can, depending on what it is, if it's like a button icon, it may be small enough that it really doesn't make a big difference. Like, you can definitely test it. Go into Windows and change your DPI settings up to, like, what is it, 250 is where the default stops before you have to do fun things, and take a look at it. And it may or may not matter. Right? Like, if you don't need to go down to something like this, it doesn't. But if you have like a designer or similar that's putting together image assets for you, quite often, whatever tool they're using will give them the ability to do vector-based art. And so if they can give you vectors, vector-based art is preferable. The only other area where you won't be able to get away with vectors, 3K monitors do not increase the elements well. I could believe that, though that's part of a Windowsy thing too, if they aren't scaling things well. The one area in WPF where you can't use vectors is your ICO file, your icon, for what's going to show up in like your taskbar or the little icon in the corner of your window, or similar. Those things have to be a .ico file. And a .ico file is basically just a bunch of bitmaps at different resolutions. So for those ones, you're still stuck doing an ICO file. Sorry. Kind of sucks. But that's all that's supported for it. You can't do vector-based ones for that. Now, with that said, shameless self-promotion. So the material design library in the demo app. So because only ICO files are supported for like your Windows icon, I got annoyed with that because the material design library, we pull in this set of icons by default, which is great. And where is it? Is it under domain? Hang on, I will find it. Icon pack view model. Yes, this is correct. This is it. Now, where is it? Copy to clipboard, set defaults. Aha! Okay, so inside the demo app, I wrote a little thing that will take the material design icon, which is a vector-based thing, and turn it into an ICO file. The thing that I ran into that I didn't like is there's a lot of programs you'll find online that will create you an ICO file, but what they often do is you feed them the image, and all they do is resize that image to each of the ICO dimensions and do that. The problem is if you have a vector-based thing, you should really resize the vector, convert to bitmap, and use each of those. And most of them weren't. They were taking the image, rasterizing it once, and then resizing the rasterized image. I'm like, what the? No! That's dumb. So we don't do that. I wrote up a little thing. This is all in the demo app, so this isn't something that necessarily ships with the library. You have to just run the demo app to see this, but you're welcome to poach the code or whatnot. But all it does is it takes whatever icon you select, runs through a list of sizes, converts it, rasterizes it to a bitmap. Again, it'll take the vector image, go to a bitmap at the appropriate resolution, add it into the list of images for the icon file, and save the icon file. That's it. It's not overly fancy, but it works. And so if you want to use one of the material design icons and all you care about is having a foreground and a background, like you may want to do something a little more interesting, right? Like this is very much fixed for doing one thing with the colors, and maybe you want something more advanced. Poach this code and do whatever you want to it. It'll be fun. So for what it's worth, that's where all of this stuff is at and where all of this is going. I'm actually surprised. I thought this thing had color selection, but it looks like it's been hard-coded. That may be a mistake, because there's this. Yeah, I'm a little surprised that these values are being hard-coded, because I would have expected it to use these color properties. I might have to double check that. But so for what it's worth, if you go through and do it, this is one example here. I'll even drop the code in. This is one sample of, if you've got a vector-based image, how you can get it down to an ICO file. It is leveraging a NuGet package that is this Blue Wolf icons. It just happened to be, there's a bunch of NuGet packages that'll do ICO generation, and actually the file spec you can find on Wikipedia. It's not that complicated. It's really not. It is literally bitmap, 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 bitmap. Done. So it gets a little complicated around different areas because you have newer formats after Windows 7 that support alpha transparency, and prior versions didn't, and so there's slight updates to the file format and that kind of thing, but it's not overly complicated if you want to roll it yourself. But I just found a NuGet package that did a good job of it and had a reasonable API and went, good enough. Syntax model. Type of expressions. Something, something, something. Okay, so type of, this gets me back here. This is no longer constructor test attribute. This is target type. We're going to go here. This is going to be, because that's already the dot type on the end of it, we're going to get it here. And this is going to be, this is a type info of the set type. And actually, we should probably move this into, we're going to subtly pull this guy out. No problem. I quite often on these streams will rabbit trail on different things. So if you have questions, always feel free to ask. Always happy to answer. Get type info. Type. Right, that's what we're going for. I type symbol. What is your problem? Possible null reference assignment. Yeah, that is a possible null reference assignment. And get target type is target type. And so I think I want to be inside. I guess it's not going to make a difference either way, will it? So we will do this, and target type. Okay. Let's see. Boom. So we We don't need that anymore. That now exists. Okay, and we know we've gotten a non-null instance by the time we get down here. So this is going to be set type to display string. Let's see, symbol display format, and then we want not fully qualified, we want minimally qualified. And then this one here is going to be the big one. I'm kind of wondering if maybe I should just attach the symbol to this thing and move on. Yeah, we'll keep them separate. Okay, so that gets us that. And now, given this type, we just want to rip through his constructors to give us the last bit, because this is currently hard-coded, and we don't want to do that. So, for each var setor in set type containing type constructors. Surprised this thing doesn't have is it because it's an I type symbol and not an I name type symbol? Is that the issue? Yep. Let's go here. Just make sure we get that. This can now be just that. Okay, so this guy here, explicit type. Okay, so for each constructor, we are just going to run through this guy. I need to get his parameters. For each var parameter in their parameters. Okay, that go. Nope, not what I wanted you to do. Explicit type, please. Gracias. Okay, so I need to create up one of these guys. Okay, so this guy here is going to be the parameter short name. So it's going to be parameter to display string. Let's see. Simple display format, minimally qualified. This is going to be the big one. Parameter to display string, symbol display format, fully qualified. And this is just the name. Parameter dot name. Boom. Okay. And then this guy just needs to be added into set null add. Boom. Boom. Okay, so that should work. We'll see. We still have the issue of collisions